Hi guys, it's Mrs. Milson. Let's go over the last check your understanding for this chapter on page 121. Okay, we're going to use two examples, one talking about the cholesterol level of 14-year-old boys that was mentioned in the example on page 120, and then this one down here that talks about Tiger Woods' drive lengths, which is from the example on page 118 to 119. Okay. So follow the method shown in the examples to answer each of the following questions. We're going to use our calculator to check our answers. So cholesterol levels above 240 milligrams per deciliter may require medical attention. What percent of 14-year-old boys have more than 240 milligrams per deciliter of cholesterol? So if we look over here, come over here, we were told that, let's see, for 14-year-old boys, the distribution of blood cholesterol is approximately normal with a mean of 170 milligrams and a standard deviation of 30 milligrams per deciliter of blood. So we're going to come over here and we're going to write our little notation. We know that cholesterol for 14-year-old boys is roughly normal with a mean of 240 and not 240, I'm sorry, with a mean of 170 and a standard deviation of 30 milligrams per deciliter of blood. Okay, so that is what we're going to put on our normal curve. Our mean is going to be 170 and our standard deviations will be 30. We could mark our 1, 2, and 3 standard deviations above and below the mean and subtract 30, add 30, and label all that, but we don't need to do that. We're just concentrating on the percent of 14-year-old boys, here's our 170 mean, that have more than 240 milligrams per deciliter of blood, so more than 240. So we just want to know that area. It's a positive z-score, so we know it's on the right side. Don't worry about marking the 1, 2, and 3 standard deviations, okay? So the first thing we have to do is we have to standardize this. We have to put it into a z-score so we can check our z-score on our calculator or in the table, but we're going to use our calculator. So if we recall, our z-score formula is the data minus the mean over the standard deviation. So for this one, our data is 240 minus our mean, which is 170, over our standard deviation. Sorry, the dishwasher's running. So we throw that in the calculator and we get a z-score of 2.33. Now recall, if I go to the table and look up 2.33 in the table, it's going to give me the area to the left. And then I would just subtract that from 1 or from 100% and get the area to the right. But we're going to use the calculator. Okay. Can you, get all this in? Okay, so second VARs, let's go down to normal CDF. Now again, our lowest number in our shaded area is the z-score, of 2.33 that is associated with that 240 milligrams per deciliter of blood. So I'm going to put in 2.33. To the right, it goes on forever. So I'm just going to put the largest number I can think of and then my standard mean and standard deviation. So it gives me an area of 0.0099. So that's approximately, 0.99%? Almost 1%. Okay, so almost 1% of 14-year-old boys have blood cholesterol that's more than 240 milligrams per deciliter of blood, which I should write that out.
You can email you at the end.
Okay. Okay, so that's my answer. Okay, so write it out again. Don't leave a number without an explanation what the number is. Never mind. Okay, so then number 2 says, I'm going to come down here. Number 2 says up here, people with cholesterol levels between 200 and 240 are at a considerable risk for heart disease. So what percent of 14-year-old boys have blood cholesterol between 200 and 240? Okay, so let me draw my curve. Oh, terrible curve. So we know 240 is over here, and we know it already has a z-score of 2.33. That's a 240. And then what did I want, 200? So 200 is going to be around here. So I want this area, okay? So all I have to do is figure out the z-score for the 200, and then I'll use my calculator to find the area between the two. So we'll z-score 200. So 200 minus 170 over 30. Well, that's 1, right? A z-score of 1. Okay. So we'll use our calculator. So our lower z-score is is 1. Our upper z-score now is 2.33. And again, this is going to give me the area between the two z-scores. So for the answer to this question, it is 0.1488. Okay, so I would say about 14.88% of 14-year-old boys. Ow! The cat is crawling up me. Boys have between 200 and 240 milligrams per deciliter.
Call from Beckley WB.
Okay, whatever. It won't be a message. Okay, so let's see.
Call from Beckley WB.
Number 3. Wait till the phone finishes. What are you gonna do? Get the cat?
Yes.
Kitty. Okay. All right. Okay. 3 says, what distance would a ball have to travel to be at the 80th percentile on Tiger Woods' drive length? Are you with me, David?
Yes.
Okay. God, the dishwasher's so loud. Sorry, guys.
The worst video ever.
I know. Worst video ever. We're almost done. Okay, let's come over here. So Tiger Woods, let's see. Come over here. I think this is where it says. Suppose that when Tiger hits his driver, the distance the ball travels follows a normal distribution with a mean of 304 yards and a standard deviation of 8. So I'm going to write my notation, 304 and 8 yards. So that's all I need to know to figure out my next stuff. So what distance would a ball have to travel, you with me, to be at the 80th percentile? Okay, so let's draw a picture and figure out where this is. So 304. And again, 80th percentile means 80% of the data is below that point. So this is 50% below and above, so it's got to be over here because it's got to be more than 50. So this is all right here, is 80%, okay? So I need to find the z-score associated with 80% and then put it back in my z-score formula. Oops, wrong one. Mu over standard deviation. And solve for the x. Okay, so the z-score, since it's area to the left, we're going to use our inverse norm. You get the calculator? So second vars, inverse norm. Area to the left is 0.8, okay? So I have a z-score of 0.8416, okay? So if I take that z-score and put it in the formula with the mean and the standard deviation, I'll solve for the x, and then I'll have the length of that shot, okay, or that drive, or whatever it's called. I don't know golf. Let's see, 0.8416 equals x minus 304 over 8. A little bit of algebra, multiply by 8, add 304, and we get something like 310.73 yards, okay? So 310.73 yards is the distance that the ball would have to travel to be at the 80th percentile. Okay? Now we can also, the cat's fine, we're almost done. We can also do this in the calculator, okay? If I go to second vars and inverse norm again, and I put 8.8 in there for my area, and then I change the mean and the standard deviation, Kitty, hold on. I changed the mean and standard deviation to the mean and the standard deviation of our situation, okay? It should give me the 310.73 yards. Can you see that in the calculator? So, all right, thank you, David. Don't have to zoom in that much. So anyway, you can see how the calculator is really going to help you out. However, I don't want all this just done in the calculator. I want to see you calculating the z-score. I want to see the work for the z-score, and then, you know, set up your formula. And you can always check this number in the calculator to make sure your algebra is right. Okay, I think that's it for this one. Okay, David, stop. All right, thanks a lot, guys. I'll see you later. Bye.
Oh, wait.